sure about or that you want to ask questions on? Joe.
Could you do number 5, please? Homework 3 or homework 5.
Homework 5, number 5?
Yeah. Thank you.
So the 3 variable system ones?
Yeah.
Okay. Okay. Joe, did you do substitution or elimination for this problem?
I tried to do elimination.
Okay. And which variable did you try to eliminate first?
I tried to get rid of the z's.
The z's first. Okay. And what did you do to try to get rid of the z's?
So that's where I got kind of stuck. Do you have to multiply by, because I know negative 3 or 15, both points 12.
Great.
So could you multiply each side by 1 by negative 3 and the other by 4?
Well, I would, since one of them is negative 3 and the other one is positive 4, I would just multiply by positive 3 and then positive 4 because you want the signs to be opposite on the z's because we're going to add them together. But yeah, that's the right idea. So maybe we'll do 3a plus 4b. That's a good set to do. And then what else? So we need another pair of equations that we can add together to cancel out the z's. So I would do b and c, where I'd multiply c by 3. Does that make sense?
Yeah.
Again, you could have done some other things there, but that seems like the easiest one. So let's write down what that is then. So 3 times 3x is 9x. 3 times 3y is negative 9y. 3 times 4 is 12z. And 3 times 23 is negative 69. And then 4 times b, so that's 4 times x is 4x. 4 times 2y is 8y. 4 times negative 3z is negative 12z. And 4 times 25 is 100. When we add down, we have 13z minus 1y is equal to 31. And then the other set, the b didn't change, so I'll just recopy that. And then 3 times c, 3 times 4x is 12x. 3 times negative y is negative 3y. 3 times z is 3z. And 3 times 25 is 75. When I add down, I get 13x minus y is equal to 100. So far, so good?
I have a question about that.
Sure.
So when you're multiplying the 3 by equation b, you don't have to necessarily do to both equations, right? B and c.
Correct.
So you can just pick one. You don't have to do like both.
Yes. Yeah, you can well, really I'm multiplying equation b by 1 if you really want to be technical. So I did multiply by something, but they can be different things. Yep. So far, so good? So these now become my new system. That we'll refer to as equations D and E. And right now, the way it's currently written, I notice that this is going to be no solution. You might be able to observe this without having to do the final elimination. Notice that the left-hand sides of the equation are identical, but the right-hand side is different. Does everybody see that? That's a situation where that indicates to us that there's going to be no solution. And you could stop right here and just say no solution. If you didn't make that observation, though, let's kind of show what happened, because again, in a stressful situation like on a test or something, you might not notice that that was what was going on. So let's just say, for the sake of argument, we wanted to cancel out the x's. Sound okay? So to do that, we'll do -1 times equation E and we'll add that to D. So D I didn't change, and then -1 times E just switches all the signs. So when we add down, 13x and -13x give us 0. -y and +y give us 0. And then -131 gives us -69. This is a false statement. When we're left with a false statement like that, that just indicates to us that there is no solution. So if you get 0 equals, something that's other than 0, that's no solution. If you had gotten 0 equals 0, that's infinitely many solutions. And if you got something like x is equal to 0, well, that's just one part of your answer, right? Does that feel okay there, Joe?
Yeah, thank you.
Yeah, no problem. And again, it's one of these that they go pretty quickly, or they can go quickly, but when you're still learning, you need to do some practice before you get the hang of it and get good at it to get fast at it, right? Till you understand what's going on and you feel confident. It's hard to go fast. But these are things that, once you get it, you can do one of these in a couple of minutes. As long as, provided you don't make an arithmetic error along the way, because that always slows everything down, right? Because then you start getting goofy things and you have to figure out why you're getting goofy things. Who else had one of these that they wanted to talk about? Yes, Megan. Does 4 come out to be a really big fraction? Well, I think I have a key written out for these. Let me look here. This is homework 5, right? I did these with the intention of, with posting these solutions after we've done the homework check. So no, number 4 should be nice, neat integer answers. Sure. I had a feeling that was what was going to be coming next. Okay, Megan. A couple of questions for you before I get going on this. Question number 1 is, which variable first? The z's. Okay. And then to eliminate those z's, what did you do? Okay, that looks good. And what else? Okay, just to point out, you've done multiplied a by 1 and c by 3. That would be fine also. But I'll do this the same way that you did it. Just so the numbers are the same as you're looking at your paper, it matches up. But in general, if you can make the smallest multiples you can use, typically makes things go a little bit easier because all the numbers stay smaller, but it shouldn't be that big of a deal. Oh, no, they just need to cancel out. Yep. So that's a good question. Okay, so let's write this out now. So 2 times negative 3x, 2 times negative y, 2 times negative 3z, and 2 times negative 8. And then we didn't do anything to 5, so we'll just recopy that. I'm going to rewrite that 4 because already it starts to look like a 9 on me. So when we do that, we have negative 11x plus y equals negative 20. And then 2 times a is the same thing that we just wrote down, so I'll just recopy that real quick. And then 6 times c, so 6 times negative 6 is negative 36. 6 times negative 4 is negative 24. 6 times z is 6z. And 6 times negative 100, or 6 times negative 20 is negative 120. So I have negative 42x minus 26y equals negative 136. Put those together into our new system. All right. So far, so good. I think so. I'm just double checking to make sure I didn't make any boo-boos here. Doesn't seem like it. Is that what you had to hear, Megan? Some like addition and subtraction. It's easy to do that, especially with the negative signs and everything rattling around in here. Let's see if we can finish this out, okay? So for the sake of argument, let's cancel the y's because it seems like that's going to be the easiest to do here. So to do that, I'm going to do 26 times d plus e. 11 times 26, that's 260 plus 20, 286 plus 26y equals negative 520. I have 42x minus equals negative 136. So if I add those together, that's negative 244 equals negative 656. Did I do that right? Six times 11. Oops, negative. What happened here? Okay, so that didn't work out the way I wanted it to. I made some kind of arithmetic mistake here. Let's look for it. Does anybody see it? God bless you. You're welcome. 2 times 2 times 2. Same. Add. Okay. 2 times 2 times 2 times 2. 6 times 6 times 6. Okay. And another motion. Where is my mistake? Where did it happen? Who sees it? Speak up. Yeah.
Did you multiply the 26 by 11?
I did. I checked it on the calculator. I mean, I did it right in my head, and then I checked it on the calculator. It's gonna be something dumb. Megan, do you see anything?
No.
One more idea.
What is that?
This is a calculator. It's just fancy, can do stuff that like yours, well, it does the same, most of the same things yours does. What I'm doing with it right now is the same thing that yours does. It's a little easier to do it. Okay. Okay, so there's a mistake in there somewhere. I just checked it. And I get the same answer when I run it that way. So there's got to be something in here that's wrong. This is so frustrating. Yes, do you see it?
Well, I don't know if it's actually a negative.
Okay. That's true, but I wrote it down here afterwards. But yeah, that's a fair point. But I don't think it mattered because I did take it with me to the next step. But yes. Good. Ah! But here's what I didn't do. I see it now. That's it. There we go. I knew it was going to be something dumb. And you're right on track there, Elizabeth. I'm even remembering names and stuff now. Look at me go. It's only been almost 2 months. I should remember some of you, at least. The masks make it harder. Anyways. Megan, is that better? Okay. So once we have this, we can find y by substituting it back into either D or E. I would choose to put it into D. So when I add 22 to both sides, I get y equals 2. And then to solve for z, I'm going to take both of these and plug it back into one of these. I'm going to plug it into equation C, I guess. So that's negative 12 minus 8 plus z equals negative 20. Negative 20 plus z is equal to negative 20. If I add 20 to both sides, I get z equals 0. So I have 2, 2, 0. But you can see here how easy it is to like make a little goofer, and it's hard to find them sometimes, right? Those little goof ups. Mine was just forgetting to copy a negative sign down. And I did it a couple places. Only one of them was really made a big problem with it though, but hopefully that's informative, help you guys feel a little bit better about how easy it is to make a mistake in here and have it be something that's difficult to find. Now, let's say, for example, this happened to us on the test, right? Let's say we solved the first value for x and we got a goofy number. Would it be better for me to erase the whole thing or to just finish it out and like write a little note, be like, I know that's not the right value for x, but I couldn't find my mistake, so I just finished the problem with it. I would finish the problem with your little mistake in there, especially if you acknowledge that, like, yo, I know this isn't the right answer, but I couldn't figure out what I did wrong. So I just finished the problem with this wrong value for x, and I know that the y and z are also wrong because of that, but I've demonstrated I understood what to do. I just made some kind of silly arithmetic mistake, like I forgot to copy a negative sign. And if that's the case, if this is like a 10-point problem, I'd probably give you a 9 out of 10. Even if all the answers are wrong, but you did all the work correct aside from like one little oops-a-daisy in there. Now, me giving you 9 out of 10 requires also that I'm able to see the work that you've done, that it's reasonably well organized, where I can see like, oh, there's the mistake. We just added 2 numbers wrong, or we dropped a negative sign, or we copied something down wrong, or whatever. But I'd much rather have you give me an answer that's wrong. You tell me like, yo, I know this is wrong. I tried to figure out why it's wrong, but I couldn't figure it out, or I ran out of time or whatever, than to leave the thing unfinished or leave it half finished or to erase it completely. In general, if you have the process down and I can see that you understand the process and you made a little oopsie-daisy somewhere and you know you're getting the wrong answer and you know it's wrong, I'd rather have that than something that's not finished. You know what I mean? It tells me more as the teacher. Okay? But I'm kind of glad that happened, that we stumbled our way through that. That was probably a good exercise to at least give us a chance to talk about something like that, because that'll probably happen to somebody when it comes test time or whatever, right? You guys have done enough of these, a couple of these problems, and probably have had it happen to you, where you got to some point in there, it's like, yo, I know this isn't the right answer. Because the numbers are too weird. Okay. Everybody feel okay with that idea? Okay. I have one topic to talk about today. Take nearly, oops, I didn't want to start a new page. It won't practice some other stuff along with that. So here we're going to talk about solving a system of linear inequalities. So note here that different than what we've been talking about is that we're here focused only on inequalities. So in this case, our system of linear inequalities, our solution is always going to be a picture. And I'll explain why as we kind of do an example. So let's say that we want to graph this system of linear inequalities. Well, basically all I'm going to do is I'm going to graph each one of these two inequalities on the same xy axis and look for the region that includes both. So in order to graph an inequality, I need to start by graphing the line. How many points do we need to graph a line? 2. So for this first equation, I'm going to use blue. So I'm going to look at the line y equals 3x plus 5, and I'll make a little xy table. So one way that we can find some x and y values is by picking values of x and then finding the corresponding value for y, right? So for example, if I pick x to be 0, when I plug 0 in for x, 3 times 0 is 0, and then plus 5 gives me 5. So that's my value for y. And then maybe I pick 1 for x. 3 times 1 is 3, plus 5 is 8. And then I'll graph the second equation. We'll do that one in green, I guess. And I'll do the same kind of thing. I'll pick a value for x, and I'll find the corresponding value for y. So maybe I pick x to be 0, so y would give me 4. If I pick x to be 1, y would be 2. Do you guys all remember kind of finding points on a line back when you did this in geometry last year even, right? So let's go ahead and draw our graph then. 1, 2, 3, 4, 5, 6, 7, 8. So I have 0, 5. And then 1, 8. And then remember, when I have a strict less than, a strict less than inequality, a solid line or a dashed line? Dashed is correct. And if it's a less than or a less than or equal to inequality, do I shade above the line or below the line? Below. These are the same rules that we had for last chapter, right? So there's my shading. Now I'll graph the other one. So I have 0, 4, and 1, 2. For the second inequality, should I use a solid line or a dashed line? Solid. And should I be shading above this line or below this line? Below. So my solution then is the place that's in common between both inequalities. So it's like this little region right in here. So if on your paper you only want to shade the overlap, that's fine. Or you can shade both regions as long as it's easy to tell what the overlap is. Is that okay?
That's the whole problem.
That's the problem. Not bad, right? Should be fairly easy. Can this get any harder? I mean, not really, but it could get trickier. So how could we make this trickier? What if our equations look like this? This looks a little bit different than the previous problem, right? What makes this look less familiar? Yeah, it's not in slope-intercept form, right? So what should we do first? Megan? Yeah, let's rearrange the equation so it's in slope-intercept form. So for the first equation, we would need to just subtract the 2x over, right? Everybody okay there? The second equation, we would add the 4x over, and then we also need to divide by -2. What do we have to remember when we do that, though? Yeah, since we're dividing by a negative, we have to remember to flip the inequality symbol. So it's changed from a greater than or equal to a less than or equal to, because we divided by a negative. And now it's just like the previous problem, right? So again, we'll do one equation in blue and the other in green. So let's see, maybe we'll do 0 for x, that gives me 3 for y, and maybe 1 for x, that'll give me 1 for y. Is there any questions about how I'm coming up with these x and y coordinates? Again, if I'm going fast and you're not sure what I did, stop me and ask. I'm happy to slow down or to go through it again. But this is a skill that I'm hoping that we remember doing, because I'm quite confident you had done it before. But if you don't remember, that's okay. We can stop and go through it again. Let's see, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. Oops. I need a tick mark on the x-axis here, huh? Okay, so 0, 3, and 1, 1. Should that be solid or dashed? Dashed, very good. Okay, and then we'll do the green one. So there's that. And there's that. Okay, should that be solid or dashed?
Solid.
Now notice that they don't look like they're going to be crossing immediately, so what do? I'm just going to extend them until they do cross. So, had to go a little ways, but that's okay. Unless they're parallel, they're eventually going to cross. Oh my goodness, guys. What am I doing here? Those should be parallel, right? I wanted them to cross so badly when I extended them. I just must have drawn them all cockaboo-booed so that they did cross. My goodness gracious. Okay. There we go. Everybody, so far so good. Yikesy daisies. So the blue line, should I be shading above or below? Above. For the green line, should I be shading above or below? Below. Do these ever overlap? No, so what would I say? There's no solution.
So only if they overlap, you have a solution.
Right, and the solution is any point in that region that's the overlap. So if I go back to that previous example, for instance, like 0, 0 is in that overlap, right? So if I plug 0 in for x and y, I'd have 0 is less than 5 for the first one, and I'd have 0 is less than or equal to 4 for the second one. Both of those are true, right? That means that 0, 0 is one of the solutions. Now there's infinitely many because it's an inequality. There's always going to be like infinitely many if there's any overlap at all. But, so we represent it with a picture. But any point from that region is a solution. Does that make sense there? So here, if we tried to pick a point from one region or the other, it would satisfy one inequality but not the other. So there is no point that satisfies both inequalities. Does that feel okay? And that's like, you know, they don't really get any harder than doing something like that, right? They might have to rearrange a little bit, or you might get something where something weird happens, where they don't overlap, or, you know, but it's not, doesn't really get, like it doesn't, it's not any really more difficult than the previous problem, right? Like, you have to maybe think about it for a second, but what do you guys think? It's okay? Okay. Well, we're going to stop here.